Okay, so we have already seen what is Boolean expression, right? AB plus C. This is a Boolean expression, right? And you already know that this expression is same as this expression, since the precedence of and is more than or. So first you have to do and then or. So all of these are expressions. Expression means anything you can write. In a state literals, you can combine it with logic operations and you will get the possible expressions. Now what is equation? Equation is very simple. This is your equation. AB plus C is equal to AB plus C. These are same Boolean function. So this is equation, right? So if you do A plus A, you'll get A. This is again an equation. This is your OR operation because A or A is nothing but A, right? Now Boolean expression same as Boolean function. Both of them are same things. For example, if I have this expression AB plus C, this is our expression. What we can do, क्या कर सकते हैं हम लोग इसको, ये फंक्शन ए बी सी वेरिएबल्स का फंक्शन है, हम इसको तीन वेरिएबल्स को एज अ एक्सप्रेशन ऐसे दिखा सकते हैं, राइट? फॉर एग्जांपल अगर हमारे पास a plus b bar है, so this is again the function of these variables of a comma b. So we can say that this is expression is a function of a comma b. Now if you have k variables, if you have if you have four variables, Boolean variables, let us say you have a Boolean function on four variables a b c d, then in truth table number of rows will be very simple. You have four variables a b c d, so you can notice that, so you'll notice that there will be 0 0 0 0 0 0 0 1 0 0 1 0 to 1 1 1 1 1 1 and so on. Why? Because each of them has two choices, either 0 or 1. A can be 0 1, B can be 0 or 1, C can be 0 or 1, D can be 0 or 1, right? So that is how it works. So A is 0 or 1, C is 0 or 1, D is 0 or 1. So the idea is you'll have 16 rows. 2 raised power 4. So this is the whole idea. So for the same thing, if you have k variables, then there will be 2 power k input combinations. Right? So k variables, and that is how it works. So now you can say, look at over here. Now you can also see that this truth table is in standard form, because we are writing them in the order of their binary value. See, this has binary value 0, this has 1, 2, 3, 4, 5, 6, 7. See? So this is the idea. Now we have to fill this table. Let us see. If a equals to 1, let's call this function f. Then what will happen? Then directly f equals to 1. You can notice at least one of them is 1. So f will be 1. This is the behavior of OR operation. A equals to 1, then function will be 1. So whenever a is 1, the put function equals to 1. In the other situation, if a is 0, then what will happen? Then f is only dx bar. So f is 1 only and if d equals to 1, x equals to 0. Yes or no? Because when a equals to 0, then f will be 1, when this will be 1, when this is 1. Because already a is 0. So very simple. So whenever a is 0, if you take this a as 0, then the f will be 1 if this is 1. So f is 1 if and only if this is 1. When d is 1 and x is 0. D is 1. So this is how you can get your truth table. Just look at these observations which you have made. Now move on. So as we know, why we called Boolean as function. Like this is Boolean expression equals to Boolean function. Why do we call it function? This word. Why do we use this word? Because you know what is a function, what a function needs. When you say something is a function, then what you should have? Then you should have domain, you should have codomain, you should have mapping. Correct? If you say something is function, right? If you say something is function, you should have all of these three things. But if I say that Boolean expression is a function, let me give you a Boolean expression. लेते हैं ये Boolean expression a b plus c. तो हम कैसे कह सकते हैं कि ये Boolean expression जो है ये एक फंक्शन है. यहाँ पे डोमेन क्या है? और या फिर अभी सिर्फ एक सिंपल सा ए बी ही लेते हैं. So what is the domain here? This is a Boolean expression. So how we can say that this is a function? See, this is very simple. If you look at truth table, it is behaving life. If we look at the truth table, it is behaving life. Let's say it is f, and it is behaving like this: 1001, 1011, and 0001. This is the truth table that you already know. And let us call it f for a moment. Now you can notice. Now this table is behaving like a function. You can notice is behaving like this. The input combination, take it to the place. So what is your domain? Your input combination 00. If you notice that this truth table is behaving like this. The input combination is your domain, right? This 00, 01, 10, 11. Okay, A, B, right? This is the idea. Now ये जो इनपुट कॉम्बिनेशंस हैं ये डोमेन की तरह काम कर रहे हैं, बिहेव कर रहे हैं, और ये जो आउटपुट है ये हमारा को डोमेन की तरह काम कर रहा है. 0 और 1 हो सकता है, ठीक है. Input combination can be like this, right? But output can be 0 or 1, right? Domain is not 0 1. For this expression AB equals to F, the input combination is working as domain. For example, understand like this. अगर आपके पास कोई भी सर्किट है, कोई एक्सप्रेशन है, ठीक है, कोई भी एक्सप्रेशन है of these variables E, A, B, then in this how many input combination possible? E. These are the input combination. One zero, one. Right? So these are the output possible. 0 and 1. So this is the idea. So domain is your input combination and your codomain will be this. Now what will be the mapping? Mapping will be like this: 0 0 to 0, this one to this to this, and only this one to this one. Can you notice this whole thing, this diagram, and this truth table thing? This is same. So this function AB, that's why we call it a function. So अगर आपके पास कोई भी एक्सप्रेशन है ऑफ टू वेरिएबल्स, तो आपके पास जो भी दो इनपुट कॉम्बिनेशंस हैं उसके दो पॉसिबल इनपुट 0 और 1 होंगे. ये हमारा आइडिया है. तो हमारा ये फाइनल कंक्लूजन है. नोट: why Boolean expressions are called Boolean functions? Then the idea is very simple. Basically, on one side what you do, you write a Boolean expression on three variables. A, B, right? These are your variables A, B. This is the expression. From expression point of view, this is your truth table. This is 0 0, this is 0 1, this is 1 0 1 1. For example, 0 1 1 0. From this truth table, you can notice what is the expression A exclusive or B. Yeah, A XOR B. XOR is your expression. Now what you can notice is that same thing as a function. How you can say function? Domain will be the input combinations. 0 0 0 1 1 0 1 1. Let's assume A comma B. Output possible will be 0 1. These are your codomain. Now your mapping will be very simple. So have code domain, you have codomain, and you have mapping. Okay. Now you can call it F. F of A comma B. Input combination works as domain of Boolean function and output works as codomain. And who will work as mapping? The expression itself works as mapping. Mapping of Boolean function. So that is why we say Boolean expression and Boolean function are same things, because this truth table thing is same as the diagram that we made, like this one. This truth table is same as this, right? Our previous truth table was same like that. And one more thing is that every expression corresponds directly to a circuit of logic gates. For example, if you have any expression, then you'll have an input gate combination of it. So we have already seen this in first lecture. You can watch the lecture number 1. Now, so for example, this is your expression over here on two variables a comma b, and your expression is a dash plus b. Then what will be the circuit diagram? The circuit diagram, the logic gate diagram will be somewhat like that. A complement, and then you can have an OR gate like this, and this will be your complement, like this. So this is the logic gate circuit. Now let us fill another truth table. Let us take xy plus x4 x1. What is here this expression? This is your exclusive NOR, x NOR. So how many rows? Then if you have then two variables, then 4 rows, any 2 power n rows. Since this is exclusive OR, then this will be the truth table. We have seen all of this earlier. The next topic is complement of a Boolean function. How to find complement of a Boolean function. Let's say you have a function over here on two variables a, b, a comma b, 0 0 0 1 1 0 1 1. Then tell me what will be the complement of this function if we are looking for f complement. It will be 0 1 0 1. Quite simple, because f complement means for every combination it will be the complement. 1 complement 0, 0 1 1 0 and 0 1. So can you notice what is this f a comma b? What is that? This is same as b complement. F a comma b same as b complement. So this is your, and what is this f complement? If f is b complement, then what should be f complement? That should be b only, and that is same as b. You can see both are same. So this is the idea. So if you have any function, then for example, if you take three variables, whatever, let's say you have another function over here, like this. So you can have 0 0 0 0. See, this over here, a comma b is same as 1. This is whole is 1. Then what should be f complement? That should be same as 0. You can see like this. No problem. You don't have to use both the variables. Now tell me, is it possible that f is equal to f complement? Is it possible? Tell. F and f complement are same. Is it possible? The answer is no. Because whatever f you take, if f is anything, for example like this, 0 1 1 0, then your f complement will be 1 0 0 1. You can never make them same. If your f is 1, then your complement will be 0. ये कभी सेम हो ही नहीं सकते हैं, right? So answer is no, not possible. They are never same. So we can say that f is never equal to f complement. Now let's see laws of Boolean algebra. Right? So all of these laws we have seen many times. Okay? Same laws you'll study in propositional logic, in discrete mathematics, in set theory, group theory, and same laws in the Boolean algebra. No, Boolean lattices. So actually all of these laws are same. All of these fields are actually isomers to each other. They are different fields, completely different, but they are kind of isomorphic to each other. They are similar. So all of the rules you'll study, they are basically same or similar, or the word is isomorphic. Now let us start with the Boolean algebra part. Now we're going to see some quick. First thing is the domination law. Some people call it annulment law. Why is it called domination law? Because this one will dominate the OR operation. This will dominate the OR operation, A or 1. So this will be 1. Now you can notice that this 0 will dominate the 1 will dominate the OR operation, 0 will dominate the AND operation. That is why it is called domination law. And why it is called annulment law? Because this A is gone. Now how to prove them? The method to prove them is this: A plus 1 equals to, so what will dominate, right? B plus 1, C plus 1 is 1, BCA plus 1 is 1, alpha plus 1 is 1. So that's how it works. Right? 1 dominates the OR operation and 0 dominates the AND operation. Let's see the proof. A plus 1 here, 1 is fixed over here, then A can be 0 or 1. Right? If it's 0, then what will be the final result? 1. If it is 1, the final result should be 1. So whatever you do with A, the final result should be 1. Hence, this is the idea. The same thing you can do for A dot 0. It can be either 0 or 1. This is fixed, 0 is fixed. What will be 0? Then it will be 0. If 1, then 0. Then whatever you do with A, final result will be 0. Is this clear? So whatever you have plus 1 equals to 1. It doesn't matter over here. And similarly, whatever you have multiplied by 0 will be 0. This is the entire idea. This is the domination law. Now, first tell me few more. What is A exclusive or 1? Let's find out. 1 is fixed again. A can be 0, A can be 1. If A is 0, then what should be the final result? A is 0, then 1. Final result should be 0 over here. So what is the final result? Opposite of A. Opposite or Complement of A. This method would help you many times. Let's find out another one. A XNOR 0. A is 0. What should be the final result? XNOR. Then final result will be 1. 1. Then the final result should be 0. The final result is again complement of A. Now, if we talk about A XNOR 1, then what will be? 1 is again fixed, 0 here, 1 here. If A is 0, then final result will be 0. If A is 1, the final result will be 1. Final result is same as A. So, the answer will be A. For A bar exclusive or 0. This A bar can be 0 or 1. If this A bar is 0, then the final result will be 0. And if it is 1, then 1. The final result is same as A bar. So like this, you can see. This method is very interesting. Many things you already know, but this method will save you a lot of time. You can do it in your mind. Right? You don't need to pick your pen or lift your pen. Whatever. Now again, few more. A exclusive or 0. What it will be? Think about it. If A is 1, then it will be 1. If A is 0, then it will be 0. So it will be same as A. If A bar is there, plus there is 0, anything with exclusive or with 0, you'll get the same thing. Anything exclusive or with 0, you'll get the same thing. Now anything exclusive or with 1, if alpha is 0, then the result will be 1, and alpha is 0, right? So, and if it is 1, then it will be 0. So the result is complement of alpha. So whatever you have exclusive or with 1, then it will be alpha bar. If you have A bar exclusive or 1, then it will be A. So quite simple. Is this clear? Yeah. Now next law is identity law. A plus 0, you'll get A. A dot 1, then you'll get A. So why you call this identity law? Then you'll understand this in group theory. Right now this name doesn't matter to us. In discrete mathematics you'll study, even in a detailed manner. Right, so over here, look at this. This is fixed. A 0, final result 0, 1, 1. Final result is same as A. So this is again the idea. Is this clear? Very simple. Now what do you think about A dot 1? This is fixed again. A is 0, A is 1, then final result will be 1. So the final result is same as A. This is the identity law. The third law is now the idempotent law. Idempotent law. A plus A, which is equals to A. A dot A, which is equals to A. This is something that you can very easily prove. So this is your repetition again. This is the law of repetition. Again, like here you have repetition. Law of repetition means A may A plus A is again A. A plus A, what should you write? A can be 0 or 1. If A is 0, then what is A? A is also 1. So then the answer will also be 0 1. So again it will be A, right? So no matter how many times you do it, it will be same. Now what do you think, A exclusive or A? So when you have same things, then it will be 0. A exclusive nor A 1. Then what is none? NAND and complement. So NAND is again or complement. NOR. This is NAND, this is NOR. First you do OR, then you find complement. So this will be the idea. This is the law of idempotent. These two things are called idempotent law. And the proofs are very easy. These are the proofs only. Alright, the thing that you have understood. Next is the fourth one. It is complement law. Law. What is the complement law? It is something like this. A plus A complement. So these are different. They are opposite of each other. So it means if one of them is 1, then another is 0. Because they are different. A and A complement. So one of them will be 1 and another will be 0. So this is your complement law. Now let's see these things. A exclusive or A complement. Remember they are different. They are always different. They are complement of each other. तो आपको क्या मिलेगा 1. Then what is this? They are again different. Like this. You'll get 0. For NAND, 0 complement, which is 1. And what is NOR? A plus A complement, which will be 0. This is quite simple. Now there is something called double complementation. What is that? It is something like if you do complement complement, then you will get A. If you have anything alpha complement again complement, you'll get alpha. So this is your law, right? Now let us see commutative law. A plus B, that is same as B plus A. This is the commutative law. So this is commutative. Now, is exclusive or commutative? Like, is it same as A exclusive or B, B exclusive or A? This is also commutative. This is also commutative. This NAND is also commutative. And then this is also commutative. Next, after that, next is associative law. It is something like this. If we do A, B, C, is it same as A, B, C? Whether we do this, both are same. Yeah. So this is what your associative law is. Same as A plus B plus C is same as A plus B plus C. This is your associative law. Now there is one more interesting idea. Now how to prove these things? This idea is very important. Like for example, this is the idea. Note by case method. What is this by case method? Let's prove this. Now let's prove it. Prove A plus B plus C equals to A plus B plus C. If you prove it, then what is the most stupid method? It is the truth table. And it will take a lot of time because both of the truth table will be same. Now let us see a good method. By case method. Okay? What this method will do? Take any variable. Right? One variable. If we have variable A, then what are the cases possible? Only two cases are possible. Either this variable will be 0 or this variable will be 1. Any other case possible? No. Okay? Only two cases are possible. Let's call it LHS and this one as RHS. In case 1, LHS is B plus C, RHS is B plus C. They are same. These two expressions are same. LHS equals to 1. RHS equals to 1. Same. In every case they are same. They will be same. So this is the proof. Whatever case you take, only two cases are possible. So LHS will be same, RHS will be same, LHS will be same, RHS will be same. So conclusion, in every case A plus B plus C is equal to A plus B plus C. This proof is more interesting because you don't waste your time on truth table, creating 8 rows and then truth table for both of the size, LHS, RHS, and then for example you have three variables. Let's say another example. Now what are the combinations? No, what are these cases? What can I say? These are basically a equals to 0, and this is your cases of a equals to 1, the first four and the last four. Is this clear? So if you have a truth table, any function a, b, c, so these first four cases are a equals to 0 and here a equals to 1. So only two cases are possible. So this is the idea behind by case method. For any variable x, any only two cases are possible. So this is the idea. Now let us see, is this XOR associative, exclusive, or C like this? Can we do this or can we do this? Both are associative. So here again you can apply proof by case method. So either a equals to 0 or a equals to 1. If a equals to 0, then what will be LHS? And over here 0 exclusive or B? Try to recall. When A is 0, when B is 1, it will be 1. B is 0, it will be 0. So it will become B exclusive or C. What is RHS when A is 0? This is your alpha. Consider this as alpha. Alpha XOR 0 is your alpha. It is again B XOR C, and this is again same. You can see they both of them are same. And if A is 1, then LHS, RHS. 1 exclusive or B, that is B complement. B exclusive or C. And when A is 1, then B exclusive or C and whole complement. So first you have to see that they are same or not. Now let us see if they are same. LHS and this is RHS. So are these expressions same? The LHS and RHS by case method. If B is 0, then what is LHS? And B is 1, then this is 1. So over here, if C is 1, result will be 0. If C is 0, then result is 1. So C is complement. And for RHS, B is 0, then it will be C complement. Again, this is same. and in this case LHS and RHS, B is 1 again, then it will be same. They are same. LHS equals to RHS. So only two cases are possible. In every case they are possible. So this is how you can say. So this exclusive or this is associative. This method is important. So remember, all of these operations are associative. What are associative operations? This and, or, XOR, XNOR. Non-associative operations, NAND, NOR. So you can try this as your homework, or you can try it by yourself. Now let us see why NAND is not associative. Can we say that A NAND B NAND C is same as A NAND B NAND C? Can we say that these are always same? They are not always same. You can very easily see, say by case method. Again you have two possibilities. Either A is 0 or either A is 1. 0 NAND B, that will be 1. Since 0 NAND anything is 1 and 1 NAND anything, 1 NAND anything, that will be the complement of the other thing. So here this will be C complement. Now for the RHS side, the 0 NAND anything, it will be, that will be 1. Are they same? They are not at all same. Definitely not same. So we can say that they are not same. You don't need to say A equal to 1. You don't need to check. You failed in the first case only. Like for NOR, 0 NOR anything. What is that? That is A bar. NOR, 0 NOR A, that simply means first you do OR, then you do complement. So OR and complement. So then what is 1 NOR A? That is same as 0, because 1 NOR A, first you do OR, then you do complement, that is 0. Okay. So NAND comma NOR are not associative. Next is De Morgan law. This is very important. Very, very, very important. This is something like this. A plus B complement, then it will be A complement into B complement. And if you have A B complement, it will become A complement plus B complement. This is your De Morgan law. And the proof is again very simple, by case method. Let's prove it. For example, A plus B complement equals to A complement plus A complement B complement. Let's prove by case method. So either A will be 0 or A will be 1. In this case, it will be B complement. And what will be RHS? It will be B complement. Here what is LHS? 0. Here what is LHS? 0. So we're getting same in every case. So this LHS is same as RHS in every case. Similarly, you can prove the other one also. This one. This by case method will save a lot of time for you. So all the laws we have seen, one that is remaining is distributive law. This is the last one. Distributive laws. What is it? Now this is again very simple. A dot B plus C, what that will be? That is same as AB plus AC. Alright? This dot you can distribute inside. AB this is AB plus AC. Similarly, you can do A plus BC. So we'll do A plus B, A plus C. A plus B, A plus C. Like this. Is it clear? So this is the distributive law. And how you will prove it? By case method. Again. You can try it by yourself. You should be confident enough now to do it by yourself. Let me do the second one first. You try the other one. A plus BC equals to A plus B and A plus C. Then what will be the proof by case? So A will be 0, A will be 1. If A is 1, then LHS will be 1. RHS will be 1. LHS will be BC, RHS will be BC. So we'll get same. So that's all for this class. We'll meet in the next lecture.